Hi, I'm Dr. J.Ann English from the University of Manitoba, and this is a group of people from the University of Manitoba, students and postdocs.
Hi, I'm Lauren.
I'm Erica.
I'm Miranda.
Blair.
Hi, I'm Tasha. Relax, some of us start with a little glass of wine, and I hope you join us and have fun during your tutorial sessions with these videos. Okay, so this is the International Year of Astronomy, and we're probably all interested in making images that we can share with the public, our family, our friends, and our colleagues as well. So, Cosmos versus Canvas, tensions between art and science in astronomy images. It's really interesting that in each image that's made, a color image for public outreach, that there's a struggle between the scientific content that you want to get across and the visual composition. Our question here is, can we strike a balance during the International Year of Astronomy? So the overarching goal of the International Year is to offer an engaging astronomy experience to every person in Canada and to cultivate partnerships that sustain public interest in astronomy. Now, not everyone will manage to get out to look through a telescope, so part of that experience includes viewing images that have been created, and that might be displayed in concerts and exhibitions. One of the things we can do is create partnerships. We're here all members of the Canadian Astronomical Society, which is a professional society. We'd like to create partnerships with members of the amateur societies, such as the Royal Astronomical Society of Canada. There's also a French-Canadian Society, Fédération des Astronomes Amateurs du Québec. And what we would like you to do is to create public outreach images and submit them to the IYA, Canadian Curatorial Team. And you can submit your images to this email address here. I'll tell you more about that later. Here's the outline at the top. We're going to talk about outreach images and the culture of science. That's one we're all familiar with. So we have to ask, what are outreach images and what are our goals for them? And then we're going to do some talking about the technical aspects about how they're made. Another video that goes along with this will be doing the hands-on nitty-gritty, and we'll work in a workshop and make some images. But the important thing, the most important thing, is visual literacy. You want to make sure that your audience can read your images. Visual literacy. Well, visual grammar of the picture plane. We talk about a picture plane because the picture plane is square, so it's a plane, like of a painting. And all this means is that we need to know how to state our composition and color harmony and their effects so that they can be read by our audience. Color theory, it's not really theory, we'll actually see it in action. And in this talk, we'll talk about how we retain the scientific information in our outreach images. I'll give you some examples because, of course, you don't want to lose that either. These images are not only good for public outreach, they're also going to be great for your publications and for insight for your colleagues. Here's something that we have a problem with in science. When a scientist creates an image that's particularly clear to themselves, they think the public's going to love it. These images here there's this purple splotch, and over here there's this big orange splotch. What these images are showing are outflows from galaxies. Right? But there are no galaxies that look orange and turquoise or purple and orange. Okay? So the public doesn't understand these images, even though it clearly shows that there's this huge fountain of gas rising out of the galaxy to astronomers. So these images operate like an analogy to looking at pictures of the Earth. This would be like looking at a globe where you have Canada colored pink, instead of looking at an image of the Earth photographed from space. And I think what we want to do in astronomy images is keep that scientific information where there's a very nice gas bubble, but we want to make it look more like a photograph from space than like contours on a globe. I can start here in giving you examples of what are public outreach images, but I'd like to first ask you why you think we should make them and what you think they are and what your motivations are.
So I feel that astronomy images would help me understand the data that I've collected.
Yeah, that's really good because to tell a little story here, what happened for some of the astronomy data was one colleague talked to another and said, don't you think they're ruining our images by making them too pretty? And she said, no, there's science in there I never saw before they made the color image when we were at the Hubble Heritage Project. Do you like color images, Erica?
Yes, I do. I think they actually generate a lot of interest for the thing. I know I was very interested in them when I first. I have a book of Hubble Heritage images that I really like that basically got me interested in the first place. So.
Got you interested in astronomy in the first place?
Yeah.
Wow, so they're really powerful.
Mm-hmm.
Yeah, I can think of something that's actually pretty important, which is all your funding, some of you are NSERC students, that's coming from the taxpayer, right? And actually, the taxpayer wants to know what we do. And a picture is worth 1,000 words. And what can we give them back? An astrophysical journal article? I don't think so. They won't get it, right? But we can give them something. And I have been told by people, you know, just in my family, if we got the information out there more and more often, they would be much more willing to fund astronomy. Is that still running?
Yeah.
Okay, sorry, that's the cat. Okay, let's start again. Public outreach images, what are they? Outreach images are those used in textbooks and magazines. Okay, so we've all seen them. And they're meant to be a bridge between the general public and scientists at the level of piquing interest. Okay, what do I mean by that statement? They're not supposed to tell you all the science that's going on. They're supposed to get you excited, like Erica got excited. They're supposed to pique your interest. And then you can go off and do some more research and find out more about it. There used to be specific outreach projects. Historically, a small percentage of telescope time was given to photographers like David Malin at the Anglo-Australian Observatory, and they would go out to produce images. So here's the Crab Nebula by David Malin. Really interesting thing about this image, David made sure that the film that he used and the way he processed it and the filters that he used on the telescope would create true color images, meaning that it would be the color that your eye would see if your eye was as sensitive as photographic film. So if you ever want to know what an object looks like in terms of color, you can go to David's photographs. Okay, let's zoom in. We're going to zoom in to like the center of the Crab Nebula. Now we're going to look at a Hubble Space Telescope image of it. It's very colorful, isn't it? This is by Bill Blair, and this is another way of public outreach images being produced. Public outreach images can be appropriated. So you make an image for your journal paper, and along comes a journalist, and they take it and they put it out. But this image was really meant for communication with yourself, with your colleagues, and for your own personal insight. And indeed, these images need a legend. Okay, so here's Bill's legend. See how the faint blue gas seems to envelop the other colors? That tells us that the hotter, lower density gas surrounds a denser, clumpier gas, and the other colors cool, while really actually hot, etc., etc., etc. You cannot understand this image unless you have a legend. The very same data. Specific projects to appropriate other scientists' data, that's the Hubble Heritage team. So we take Bill's data, and we have the skills to put it together in a way that's quite appealing and retains the information. So in this image, you still have colors that represent actually the chemicals, and the chemicals represent the temperatures in this nebula. Okay, so what we did was we used archival data collected for scientific purposes. That means it can never be true color images. It's only narrow band imaging. Right? Most of the data are observations acquired by other scientists. We have to work with them. And it's produced by a team, but each image had a lead image maker in that team, and then we would decide on the final product together. There's the team, early on. I'm a short one.